Look around the room you're in right now. Your phone, your keyboard, your shoes, the coffee machine, the chair, the lamp, the spare cable in a drawer that you forgot existed. At some point, many of these objects probably traveled inside the same kind of metal box. Not a smart machine, not a robot, not a satellite, a rectangular steel container. It is so ordinary that most people stop seeing it. It sits on trucks. It stacks in ports. It waits on trains. It appears in the background of action movies and news reports, usually as industrial scenery. But this box quietly changed how the modern world works. It changed what could be manufactured, where it could be manufactured, how far it could travel, how much it would cost, and how quickly it could arrive. This is not just the story of a container. This is the story of how a boring metal box became one of the hidden systems behind everyday life. Before containers, shipping was not one clean system. It was a long chain of human handling. Cargo arrived at a dock in separate pieces: barrels, sacks, wooden crates, bales, boxes, machinery, furniture, tools, food, textiles. A ship could carry hundreds of thousands of individual items, all shaped differently, packed differently, and loaded differently. Workers moved goods from trucks or rail cars into warehouses, then from warehouses onto the dock, then from the dock into the ship. Inside the hold, more workers packed everything together like a giant, dangerous puzzle. When the ship arrived, the process happened again in reverse. Every handoff created a problem. Time was lost. Goods were damaged. Cargo could be stolen. Ships sat in port for days, while crews waited for loading and unloading to finish. The ocean voyage was only part of the cost. A huge part of the expense was simply touching the cargo again and again. This older system had a name: breakbulk shipping, and for centuries it was normal. If you wanted to move goods across the world, you accepted the chaos. The dock was not just a transfer point, it was a bottleneck. The strange thing is that the solution would not come from a naval engineer, a port authority, or a giant shipping company. It would come from a truck driver who got tired of waiting. Malcolm McLean was not trying to redesign the world economy. In the 1930s, he was building a trucking business. One version of the story begins with McLean waiting at a New Jersey pier, while cargo was unloaded from his truck and moved piece by piece toward a ship. To most people, this was just how freight worked. To McLean, it looked wasteful. Why unload the goods from the truck at all? Why not lift the entire trailer onto the ship, move it by sea, and put it back onto wheels at the other end? The first version of that idea had a problem. A full trailer includes wheels, axles, and a chassis. On a ship, those parts waste space. Ships make money by carrying cargo, not empty wheels. So the idea changed. Do not move the whole trailer. Move only the box. The cargo stays sealed inside. The box can be lifted. It can be stacked. It can go from truck to ship to rail without anyone touching the goods inside. That sounds simple now. But in the 1950s, it required new containers, new cranes, new ships, new terminals, new rules, and a lot of people willing to believe that an outsider from trucking understood shipping better than the shipping industry did. On April 26, 1956, a converted oil tanker called the Ideal X left Port Newark, New Jersey, bound for Houston, Texas. On its deck were 58 metal containers. It did not look like the future. It looked like a tanker carrying boxes. But the experiment attacked the most expensive part of old shipping: handling. Instead of rebuilding the cargo at every step, the container made the cargo into a single unit. A crane could move that unit in minutes. The contents stayed sealed. The ship spent less time waiting. The truck at the other end did not need to repack anything. The container was not magic because it was strong. It was magic because it reduced decisions. Every loose shipment asks questions. How heavy is this crate? Where does this barrel go? Can this sack be stacked? Is this machine too fragile? Who touched it? Where did it get lost? A container answers those questions with one rule: move the box. Inside the box, the cargo can be complicated. Outside the box, the system sees one standardized unit. That is the first secret mechanic. The box hides complexity. But one company's box is not enough to change the world. Imagine if every phone charger had a different shape, every train track had a different width, every website needed its own private version of the internet. That was the danger with containers. If each shipping company built boxes in different sizes, with different corner fittings, lifted by different cranes, then the box would only work inside one company's network. It would be useful, but not universal. The real breakthrough was standardization. Containers needed common dimensions, common strength requirements, common ways to lock, lift, stack, test, and transfer them. The corner fittings mattered because cranes and ships needed predictable points to grab. The size mattered because ships, trucks, rail cars, ports, and warehouses all had to fit around the same physical object. This is where a metal box becomes infrastructure. Once the world agrees on the interface, every part of the system can be designed around it. Ports can buy cranes that handle the same boxes from many companies. Ships can be built with cells for standardized containers. Rail terminals can transfer them inland. Factories can load them far from the coast. Warehouses can plan around their dimensions. The container became a physical file format for global trade. And once that happened, the most important part of the invention was no longer the steel. It was the agreement. The box hides complexity. Once containers spread, the box did something even stranger. It changed geography. Old ports had been built around breakbulk cargo. They needed warehouses, labor, and access to dense city waterfronts. Container ports needed something else. Huge open space, deep water, giant cranes, truck access, rail access, and room to stack thousands of identical boxes. That meant some historic waterfronts lost their old role. Other places grew into massive logistics hubs. The change did not stop at the dock. When shipping became cheaper, faster, and more predictable, distance changed meaning. A company could make parts in one country, assemble them in another, package them somewhere else, and sell them on the other side of the planet. A store could carry goods from dozens of countries. A factory no longer had to be near its final customers in the same way. The container did not create globalization by itself, but it made a certain kind of globalization practical. It turned oceans from barriers into conveyor belts. This is why the box is easy to underestimate. It does not look like a technology in the way a smartphone looks like a technology, but it changed the cost structure underneath almost everything. If the cost of moving goods falls, the map of what is economically possible changes with it. The box hides complexity, but every efficient system creates winners and losers. For dock workers, containerization was not an elegant diagram. It was a threat. The old system required large crews to handle cargo. The new system needed cranes, terminals, drivers, mechanics, planners, and fewer hands inside the ship. Jobs changed. Some disappeared. Port cities had to adapt to waterfronts that no longer worked the way they once had. Factories felt the change too. If it became cheaper to move goods across oceans, then companies could search the world for lower production costs. That gave consumers more choice and lower prices, but it also exposed local manufacturers to competition they had never faced before. And the container created another hidden problem. The more efficient a system becomes, the more society depends on it. When containers move smoothly, nobody notices. Shelves fill, packages arrive, parts reach factories, retailers plan months ahead. But when ports jam, ships wait, canals close, strikes spread, or containers pile up in the wrong place, the invisible system suddenly becomes visible. The box made the world smaller. It also made the world more connected than most people realized, and connected systems can transmit problems very quickly. The shipping container is often described as a box, but that is only the visible part. The real invention was a universal interface for physical goods. It allowed a factory, a truck, a crane, a ship, a port, a rail yard, a warehouse, and a store to participate in the same system without renegotiating the cargo at every step. That is why the container feels almost invisible. Successful infrastructure disappears into the background. You only notice it when it fails. A container does not care if it is carrying toys, tires, electronics, furniture, clothes, coffee, machine parts, or medical equipment. The system does not need to understand the story of every object. It only needs to understand the box. That is the genius. Not that the container made cargo simple. It made cargo look simple to the network. And once the network could treat billions of different things as standardized units, the world could move at a completely different speed. The most powerful machines are not always the ones with engines. Sometimes the machine is in agreement. So the next time you pass a container on the highway, it may look empty, ordinary, even boring, but hidden inside that shape is one of the most important ideas of the modern age. Do not move the product, move the system around the product. That is the secret mechanic of the box that runs the world.